Okay guys, sorry pinost ko kasi naubusan tayo ng memory ulit. Okay, so let's proceed. Let's continue our topic. So sieve analysis, napansin nyo, this sieve analysis, magkakaroon lang tayo ng sieve analysis testing kapag ang mismong soil mo is granular soil. So ito yung with either gravel, sand, silt, di ba? Sa hydrometer analysis mo naman, ito yung sa fine grain soils natin. Fine grain soils. Ayan. So, going back to the soil particle size classification, sabi ko kanina, meron tayong apat na organization which is your MIT, USDA, AASHTO, and USCS. So, ngayon, dito sa apat na organization na to, malalaman natin kung ano yung limitation ng gravel, sand, silt, and clay. Sabi niya sa MIT, ang gravel niya is greater than 2 mm. Sa MIT yan. Ang sand naman sa MIT, nagre-range siya sa 2.0 to 0.06 mm. Ang silt naman niya, nagre-range siya ngayon ng 0.06 to 0.002. And then, ang clay ngayon, using MIT organization, is less than 0.02. So, yan for MIT. How about for your USDA naman? Masasabi daw natin ang gravel natin, ang size ng gravel niya using USDA organization kapag ito daw rin ay greater than 2 mm. Ayan. Ang sand din niya is ranging from 2.0 to 0.05. Ang silt naman natin is ranging 0.05 to 0.002. And then, again, your clay is less than 0.002. Okay. How about yung sa AASHTO natin and USCS? Again, ito yung sasabi kong kalimitan ginagamit to classify the soil particle size. Sa AASHTO natin, pansinin nyo, ang AASHTO, classification natin, ang gravel down niya, maka-classify natin sa 26.2 mm to 2.0 mm. So, I think, 76.2, ilang inch yan? Or the inches. So, ganyan naman sa sand mo, nagre-range siya sa 2.0 to 2.075 mm. And then, ang silt mo ngayon, from 0.075 to 0.002 mm. And for your clay, parehas din siya, less than 0.002. Compare mo sa USCS. USCS natin, sa gravel mo rin, sa 26.2 to 4.75 mm. And then, ang sand mo, 4.75 to 0.075 mm. And for your silt and clays, ito yung less than 0.075. So, kalimitan, ito ay nagagamit, AASHTO and USCS natin. So, sa gravel, 76.2 to 2.0. And sand mo, 2.0 to 0.75. Silt mo, 0.7 to 0.002. And for your USCS naman, 76.2 to 4.75. 4.75 to 0.75 naman for sand. And for your silt and clay, 0.75. Okay. So, now, going back to this figure, sa sieve analysis natin, dito mo na ma-determine kung hanggang saan yung limitation ng gravel, sand, silt, and clay mo. Okay? Ano yung conversion ng sieve number 4 kapag ang opening nito is in terms of mm? So, inulit ko, ang sieve number 4 natin, i-review nyo, guys. Ang sieve number 4 natin, ito yung 4.75 mm. Okay, ang sieve number 8 mo, 2.38. Then 2.0. Ang sieve number 20 mo naman, 0.850. And then 0.425. Then sieve number 60 mo is 0.25. Sieve number 80 is 0.18. And then sieve 100 is 0.15. And sieve number 200 is 0.075. Okay? So, sabi ko, kalimitan ginagamit is AASHTO and USCS. From here, ang range down ng gravel natin is 76.2 mm to 2.0 mm. So, meaning to say, kapag AASHTO yung gagamitin natin, ang 2.0 mm dito hanggang sieve number 10. So, ito hanggang pataas up to 76.2 mm ang diameter nung gravel, nung soil particle natin, tatawagin natin ngayon siyang gravel kapag using AASHTO, guys. Ngayon, how about for your sand? Ang sand mo daw is from 2.0 to 0.75. So, meaning to say hanggang dito. Yan, ito yung sand natin. Hanggang sa sieve number 200. So, ito yung sand mo. So, ang mas mababa pa, sa may 0.075 to 0.002, ito na yung sa silt. And yun din yung sa clay naman, yung mismo sa paan natin. Okay? So now, let's proceed. How about for your USCS? For your USCS, or gravel, 76.2 to 4.75. Meaning to say, ang gravel mo, kapag using USCS, mag-start sa sieve number 4, up to pataas. Ayan, ito ang gravel natin kapag using USCS. Ayan ang gravel natin, sieve number 4 up to 76.2 mm in diameter. Ang sand naman natin from 4.75 to 0.075. So ayan, sand na daw yan pag USCS. Okay? So ngayon, dito sa sieve natin, sieve 1 inch, 1/2 inch kako sana. How do we classify this one kapag AASHTO? Anong klaseng soil siya? Gravel, sand, silt, or clay? So, dito mo lang tignan yung conversion in terms of mm. Since 12.5 ang 1/2 inch, ang range ng gravel mo using AASHTO is 76.2 to 2.0, pasok ngayon siya. So, ang diameter opening nito, kapag using AASHTO, this is considered as gravel. Okay? Next. How about your sieve number 20? Number 20. If we will try to convert the opening or the diameter in terms of mm, this is 0.85. Right? So, going back to this figure, your sieve number 20 is 0.85. Kapag USCS naman titignan natin, mapapansin natin na ang diameter nito, diameter opening niya is considered as what? Sand. Okay? So, napansin nyo, yung sobrang liit. Sobrang liit no sieve number 20. Ayan. Okay na? So, that is for your sieve analysis or for your soil particle size classification. Okay. So, I hope na na-explain na mabuti yung particle size natin. And let's proceed to your next physical properties. Number 2, ano yung sinulat ko? Particle shape. Punta naman tayo sa particle shape natin. So, sa particle shape natin, sulat ko dito, meron tayong sa one paper. Yeah. So, for our particle shape naman, number 2, particle shape. For our particle shape, meron kasi classification to particle shape. It's either number 1, it's either bulky shape siya, or ano pa yung isa flatty. Yes. Flatty shape siya. Now, through this particle shape, paano mo malalaman na ang gravel ba is bulky or flatty? Dito. So, explain natin. The shape of the particles influences the strength and stability of a soil. Take note nyo yan lagi. Na yung mismong shape ng particle, it will influence the strength and stability of your soil. So from here, we will identify whether what are the bulky soils and what is the flatty shape. So ngayon, ang bulky soils kasi natin, the composition of your bulky soils are what? Ito na, malalaman mo dito, ito yung cobbles, yan, ito yung gravel, ito yung sand, and then silt. Compare mo naman dun sa flatty shape, ito yung clay natin. Alright? So ngayon, going back to the two types of particle shape, which is your bulky shape and flatty shape. Sa bulky shape kasi natin, meron siyang apat na subdivision. Ang apat nito na category sa bulky shape, it's either angular, meron siyang 4 subdivision to 4 subdivision. Yan, meron siyang apat na subdivision. Number 1, it's either your cobble, gravel, sand, silt, or your bulky soils are angular. Yan, angular. Number 2, subangular. And number 3, sub-rounded. And then number 4, rounded. Okay. So, ito yung apat na division ng bulky shape natin. And always take note, guys, out of these 4, sino kaya sa kanila yung best for construction? Okay. Lahat, tandaan nyo dito sa bulky shape natin, if for example, sabi ko nga, ang bulky shape mo is cobbles, gravel, sand, and silt. So, ang bulky shape mo kasi may apat na division. Malalaman mo whether that's angular, subangular, sub-rounded, and rounded. So, out of these 4, malalaman natin dito kung ano yung best material for construction. Okay? So, out of these 4, guys, lagi nyo tandaan, ang best material for construction is the angular. Okay? The angular soil. So, bakit? Sabi niya, angular gravels and sand kasi, they are generally the best materials for construction because of their interlocking characteristics, but usually produce artificial by crushing. So, ngayon, napapansin nyo, ang angular kasi ngayon, nangyayari na, kina-crush nila ngayon ito. May tatawag na crush stone. Saan galing tong crush stone na to? Galing to dun sa malalaking bato. Galing yan sa boulders or cobbles. Kina-crush siya. Para ang later on, once na na-crush yung boulders or yung cobbles mo, siyempre ang form ng mismong bato mo na ngayon is angular. That is why best siya sa construction material kasi nag-i-interlock siya mismo. Minimal lang yung void spaces. So, ngayon, mas maganda yung banding. Kaya, sa bulky shape, lagi nyo tandaan, mas magandang gamitin ang angular stone compare sa rounded. Sa angular and sub-rounded. Compare sa sub-angular, sub-rounded. Kaya always natandaan, angular ang pinaka-the best material for construction. Kaya nga pag nagpapadeliver ako sa mga construction, sa project site ko sa mga project ko, kapag nag-order ako ng baton, hindi ako nag-order na rounded. Rather, sa project, always nag-order ako ng crushed stone. It's either 3/4 or 1 inch. Okay? So now, let's proceed. Your flatty shape. Again, this is for your clay materials. Again, what is the definition of your flatty soil? The flatty soil, these are the particles have flat plate, like grains with 2 dimensions much larger than third. So, ang common example ng flatty shape natin dito is for your clay. Alright? So again, the two types of your particle shape, we have your bulky soil and your flatty soil. Okay, now let's proceed to your number 3. We have here your gradation. The number 3 physical properties of soil natin is what? Gradation. What does it mean by this one? Ano ibig sabihin ng gradation mo? Ang gradation kasi natin, dito natin malalaman later on. Gradation mo, yung tinatawag niyang grading. Malalaman mo dito kung it's either well-graded siya or poorly graded. poorly graded, and then uniformly graded siya, ganun. Uniformly graded. And lastly, we have your gap graded. So dito sa gradation mo, saan ko mostly nakikita to, sir? Through later on sa particle curve natin, sa particle distribution curve natin. Kapag makikita mo later on yung particle curve mo, particle size distribution curve mo, dun mo ma-assess later on kung well graded ba siya, poorly graded, uniformly graded, gap graded, using yung USCS chart, yung Unified Soil Classification System. Kasi later on may nakalagay dun kung well graded, poorly graded, and uniformly graded siya. So may mga example naman tayo later on dito para malaman natin whether it's a well graded, poorly graded, uniformly graded, or gap graded. Alright? So for our number 4, ito naman yung tatawag nating compactness. Yan. Ang compactness naman, dito mo determine whether the soil is what? Loose or the soil is dense. Kalimitan, mapapansin natin ito sa mga construction projects, sa road construction. That is why sa next video natin, kapag i-explain ko yung about sa sampling and testing materials, marami kayong matutunan dun sa may compaction, sa field density test natin. Alright. So, it will be further discussed, explained here, yung compactness natin, whether it is a loose or dense siya. So, ang compactness natin, ma-determine natin to through the testing of what? Standard Proctor test, and sa field naman, your field density test. Kaya, later on, mas malalaman niyo pa kung ano yung best meaning ng compaction. Sa next video natin, explain ko mabuti. Number 5, we have your specific gravity. Number 6, we have your soil moisture. Dito na papasok yung tatawag nating Atterbird's limit. Your Atterbird's limit. Actually, ang Atterbird's limit, ito is the composition of your liquid limit. These are the composition of your plastic limit. Madidetermine mo dito yung plasticity index. Yan, madidetermine natin through Atterbird's limit. Kasi ang soil moisture natin, using what, ang tawag kasi dito, ang other term for soil moisture, yun yung consistency. Magde-determine tayo ng water content dito. Water content or your moisture content. Meron tayong formula. Water content and or other term for water content is moisture content. Sa soil mechanics kasi namin, ang kalimitan na notations nung water content natin is omega. Yan. This is weight of water all over weight of solid. Soil mechanics natin madidiscuss na maayos through phase relationship, weight, and volume relationship ng water content natin. But anyway, kapag magsasolve ako ng problem dito, past e-board exam or whatsoever na example or problem about Atterbird's limit, pwede ko rin i-advance na i-explain kung paano nakuha itong weight of water all over weight of solid. So, omega, water content, or sinulat ko yata is MC dun sa PDF nyo. Moisture content or water content. Okay, and then last, we have here your last? Organic soil. Ano yung organic soil ulit? These are the spongy, crumbly, gano'n, di ba? Kaya, yun. Lagi niyong tandaan. So, now, out of the 7 physical properties of soil, meron silang kanya-kanyang testing ito. Okay? So, that is why, that is our topic for your soil and soil aggregate for the meantime. So, kasi magbibigay pa ko ng example and then explain ko pa lalo yung sampling and testing of materials for your soil and soil aggregate. So, stay back, sit back, relax, and enjoy as I'm going to proceed to my next example problem solving sa particle size and how to classify soil using USCS and AASHTO. Again guys, I hope everybody may natutunan. I hope you learned something. So, from now on, I just want to thank you for your time listening for our subject construction material and testing. So, guys, um, please see my next video for our example solve problems or our past CE board exam problems. So, thank you, and again, God bless everyone.